In this lesson, we're going to be talking about certificates. So what's a certificate? Well, a certificate is a digital piece of data, kind of like a passport or a driver's license, that tells who you really are. Not only does it tell who you really are, but it gives you the ability to do things like encrypting messages. So it's a little bit more than a passport or a driver's license in the sense that in addition to validating your identity, it also gives you the ability to do some other things. So let's actually generate a certificate here. And I'll talk a little bit about what I'm doing as I'm doing it and then why we're doing this and the various things that you can use certificates for. So one of the things that you're going to be most familiar with the use of certificates for is encrypted websites. When you use an HTTPS connection to a website, you're actually using a certificate. The server has a certificate that it offers to you, and you go through this negotiation for encryption mechanisms, and that's all done through the certificate. In this case, I'm going to generate a certificate authority certificate. So I'm doing an RSA key here to use inside the certificate. So I'm generating a private key, and the private key is used as part of the certificate, and there's a public key associated with it. With certificates, you've got public and private key, and data gets encrypted with the public key and then decrypted with the private key. So they are mathematically linked, that public and private key, because you need one for one end of the communication and the other for the other end of the communication, and they have to be linked so that the data that's encrypted with one key gets to be decrypted with the other key. So this is asking for a passphrase, and that's just to protect the key. So I'm now going to generate the certificate itself. And you can see I'm using the OpenSSL utility here. I'm doing a new certificate that's going to be a new request that's an X509 certificate. It's going to be valid for 365 days. The key that I'm using for this certificate is called ca.key, and then the out, I'm going to call it ca.crt. And since I'm accessing the key, it wants the passphrase for that. And now it wants me to fill in a bunch of information. So I'm just plugging in information that's going to be inside the certificate, that's going to be stored in the certificate that I can verify. I'm going to call this root. So now I have a certificate, and I can take a look at it using OpenSSL, and this is going to be useful if you ever need to take a look at a certificate. You can use OpenSSL, and you're just going to say it's an X509 request to OpenSSL, and I want a text. So I want text output, and the input is going to be my certificate file. And here's actually the certificate itself, and you can see all of the data that's stored inside the certificate. So I could use this CA to generate a self-signed certificate, and while there's certainly nothing wrong with that, there's also nothing that guarantees that you are who you say you are to somebody accessing this particular certificate. The self-signed certificate gives you encryption, but what it doesn't really give you is that validation that you are who you say you are, and that's what we call non-repudiation. What non-repudiation means is you can't say that you didn't send a particular message if your key was used to generate that message, particularly if you've protected your key by password protecting it. Since you're the only one who is supposed to have your key and also have the password, it's a lot harder to say that you didn't generate a message if your key was used because you had the key and you had the password and nobody else had it. So in addition to encryption, we can do things like we can digitally sign messages like email. You could digitally sign an email, and that doesn't give you any privacy, but what it does give the person on the other end is some proof that you were the one who actually sent it and that it hasn't been tampered with in transit. Because certificates have this validation using a secure hashing algorithm. And you'll see here that the signature algorithm is SHA-1 with RSA encryption. So we're using RSA encryption, but we're also using SHA-1, which is a secure hash algorithm, which verifies that the message that's received is the one that's sent, since we generate a hash so that we can check both ends to make sure that the data on both ends is the same. So while we did a certificate authority here of our own, there are certificate authorities where their business is being a certificate authority. And I mentioned doing this validation thing. And the validation is where the certificate authority makes sure that you are who you say you are by using some form of identification prior to issuing you your certificate. That way you don't have any sort of confusion about whether the person is who they say they are or not. Since a certificate authority is supposed to be a trusted entity, and that trusted entity says, yes, Rick, you are who you say you are, everybody can be assured that that's true. Without that certificate authority, you're a little less certain whether somebody is who they really say they are or not. So a certificate authority has to have its own certificate, which is what we generated a little bit earlier, and that's because the certificate for a user is effectively signed with this certificate for the CA. And that CA certificate then has to be installed pretty much anywhere the certificate is going to be used. So here's an example. Let's look at Firefox. And we can view the certificates that are installed on this particular computer here in this browser. So I'm looking at the certificate manager for Firefox, and I see there's an authorities tab. And here's all of the authorities that have either been built into Firefox here or have been added in some way. And you can see here that I could do an import of a certificate that I've generated, and here's an example of one, the ca.crt. I could open that up, and it's telling me it's already installed. So there's a certificate here that I created as a CA certificate that's already been installed in this browser as a certificate authority. So lots of authorities here, and every one of these is capable of creating certificates for users or for servers, and any certificate that's issued by these CAs would automatically be trusted by this particular browser. If we ran across a certificate that had not been issued by a trusted certificate authority, we would get a message indicating that there's a certificate error, and then you'd have to go through a process of generating an exception or some other process to say, yes, I really want to go to that website. So that's some of the basics of certificates and their use.